Hello. In the second part of this section's video, we're going to look at the modeling process through a specific question, and that is, how much does it cost to drive my car? So, as you may recall from our last video, the modeling process looks something like this. We have a real-world question, and then our next step is to define the problem. So what you want to think about before we jump into this is, what are some assumptions you need to make? What are the important variables? How might you simplify this question so it's a more manageable problem? Because right now this is so open-ended and so vague that there's a lot of different ways we can go. And often the define the problem stage probably involves some back and forth with whoever actually wants to know the answer to try to find out what do they really want to know. So, since you don't have a specific client to have that conversation with, I'm going to give you a few more details so you can have a direction to proceed in. Let me give you two scenarios. One scenario is I'm choosing to either ride my bike to work or to drive my car. My car gets about 20 miles to the gallon, and it's about a 7-mile round trip. If I decide to bike instead of drive, how much money am I going to save every time I make that trip? Another scenario might be is if I'm going on a long vacation or a long ways away for a conference. For example, one year I had a conference in Tampa, Florida. So that's about a 2,500 mile round trip that I would have to drive if I decided to drive instead of fly. The car I would drive would probably average 35 miles to the gallon on the highway between Kansas City and Tampa, Florida. And so the question is, from a financial point of view, how much money am I spending or saving if I choose to drive versus fly? And notice we're not going to worry about hotels and extra food. We're just curious about the driving aspect of that question. So take a moment, pause the video, and ask yourself, what are the relevant variables and what might you do to kind of clean up this problem to make it manageable, and then we'll talk about it more. All right, so let's jump into the variables first of all. No doubt you came up with a couple of the obvious ones. For example, the number of miles is certainly going to impact how much it costs to drive a car. The MPGs, I already mentioned that. That's going to make a difference. Another one is the cost of gas. Certainly if gas goes up, so is my expense. But as you think more about it, there might be some other things that come to mind. For instance, insurance. Right? That's certainly the part of the cost of driving a car, as is taxes, as is maintenance. You have to get oil changes, keep your tires in good condition. Things are going to break, so there's going to be repairs. And there's also maybe not so obvious, but just as important, as depreciation. Certainly my car is going to depreciate over time, but the more miles I drive will also depreciate the value of the car. So if I want to trade it in down the road, the more I drive, it's going to get me less on a trade-in. Now, this is a lot of variables. This would be a lot of work to come up with a model. And because part of the modeling process is to start simple, we're going to try to pare this down some. And notice some of these variables aren't really even appropriate. For example, if I'm just talking about driving my bike, riding my bike to work or driving a car, then insurance and taxes don't really matter, because I'm not getting rid of my car. I'm just using a different mode of transportation. So I'm going to have to pay those whether I ride my bike on a particular day or not. Notice these last three are all important, but they are harder to think about. So we're going to wait on those, right? Because these are a bigger question mark of how we might proceed. But notice these three are pretty straightforward, and those are definitely important, right? We can't ignore those for sure. And so we're going to focus on that for now. So notice define the problem means that when we're done with this stage, we should have a more specific problem that we can tackle. And so let me give you one version. In fact, you might, again, pause the video and try to write down a more specific question that's more useful and helpful to analyze than this original one I gave you. So here's how I would write it. So what is the cost of the gas? Right, so that emphasizes that we're not worried about repairs and things. What is the cost of the gas to drive my car for a specific trip on the highway or in the city? And I phrase it that way is that we really want a trip that's either all city or all highway, because the MPGs are generally easier to estimate rather than if you're mixing those two. And for the examples I gave you, one was pretty much all city driving and the other one was all highway driving. So this would fit within those parameters. All right, so that's the define the problem stage. The next stage is called build the model. Now, normally there would be potentially a lot of mathematical work to do this stage. We picked a pretty simple problem, especially since our only variables we're worried about is miles, MPGs, and cost of gas. So again, take a moment and ask yourself what the formula would be. It's not hard, and I'll write it down here in a minute. All right. So the output is going to be cost. We have 3 input variables, and as hopefully you were able to write down, it depends on them in this way. I need the total number of miles driven on the trip divided by the MPGs that my car gets times the price of the gas. Okay, so this is going to be the total cost as a function of those 3 variables. Now, one thing you can do to kind of double check your work is to look at the units and see if the units work out both ways. For instance, I know on the left side, the units of my cost should be dollars. But what about on the right side? So of course, the number of miles is just miles, so that's really not anything new. MPG, of course, is miles per gallon. And then the price is going to be dollars per gallon. And so what we see is that the miles is going to cancel, numerator and denominator. Gallons is in the denominator of both, and so those cancel. And so all we're left with is dollars on each side. That doesn't prove our formula is correct, but if they didn't match up, it would definitely prove that it was wrong. So that's a good sign. Now, again, this stage would probably have more work, but for our purposes, we're good to go. So let's move on to the next stage. The next stage is analyze the model. So here's where we look at our model and see, does it make sense? Is there error? Is there, what sort of error could be a part of the model? So for example, MPGs, I mentioned my car gets around 20, but it's not exactly 20 all the time. Or on the highway, it's not always 35 on the highway. Or the price of gas. For our problem, let's assume $3 per gallon. But of course, it's not always $3 a gallon. So that's not going to be a perfect value either. The miles, we have 2 options. One was a 7-mile trip. The other one was a 2,500 mile trip. All right. And then this one was a 20 MPG car. And this one was a 35 MPG car. Now, we have three variables. We can't graph a function of 3 variables all at once very easily. So it's nice to fix 2 of the 3 and then see a graph of the 3rd one. And so that's what our next picture here shows. And that is assuming that our function is based on the price of the gas. So as the price of gas goes up, notice how does my cost to drive that 7 miles. So this is based on the 7-mile trip. All right, 20 mpg car. And so if you just care about specific numbers, right, you can look at this and notice that it's about $1.05. $1.05 per trip, or about 15 cents per mile if you prefer. So a couple of different ways of analyzing the model. You can think about it in terms of cents per mile, dollars per trip, or you can even make general statements like, as the price of gas increases, the total cost increases in a linear fashion. All right. Notice though that maybe I want my independent variable to be something different. Maybe I want the MPG to be the independent variable. Here we get a very different graph. Notice at 20 MPGs, I still get $1.05, right? So this is still price is equal to $3 a gallon, right? 7-mile trip, so that hasn't changed. But now you can see as the MPGs improve, the price, the total cost is going to decrease in not a linear way, but in a concave up decreasing way. And in fact, the benefit of going from a 10 to a 20 mpg car is much more significant than going from a 30 to a 40, right? Or a 40 to a 50 especially. So those are the sorts of things that we might be interested in, or we might just care about the actual value. What about our trip to Tampa? So our trip to Tampa, remember, was 2,500 miles. So that works out to 8.6 cents per mile, or a $214 trip cost. Again, just for the gas. So now we ask ourselves, is that good enough, right? Is this a useful enough answer to help me decide whether I want to drive or fly based on expenses? But remember, if we go back to our assumptions, and this is part of the analysis part, I ignored a lot of variables here. So the best way of thinking about this number is that this is a lower bound. All right, so I can be confident that the price of gas, unless something really changes dramatically with the price of gas, that I'm going to spend at least $214, not to mention depreciation and everything else. So if I can buy a plane ticket for about $200, then I should probably definitely do it. But what if I have a family of 4 and we all want to go together? All right, notice if I'm driving, this number doesn't change, but buying 4 plane tickets, even at $200 a plane ticket, is going to be a lot more expensive. So now I have to ask myself, all right, this is a lower bound. How much more could that number actually be? And how much does the price of gas change? Because presumably I'm predicting in the future. Well, it turns out that if I had a plus or minus 25% or cent per gallon change, that would translate to about a plus or minus $18 for the trip. So that's not a huge change. So I could, if I felt confident that gas wasn't going to change dramatically in the next few months that I'm planning the trip, and I was willing to kind of absorb an $18 plus or minus, then maybe my model is good enough that a little bit of error in the price of gas isn't going to change my output. But what is more concerning, though, are those other factors. For instance, some websites will tell you that it costs you 62 cents per mile to drive a car. Now, if you calculate that times 2,500 miles, you're going to get a whole lot more than $200 for the trip. And so now that plane ticket may actually be a good deal even for all 4 of us to go. But 62 cents versus 8.6 cents, that's a huge difference. So now I have to ask myself, what's going on? What about my model versus their model is different? And which one is more reliable, or is the truth somewhere in between? So before I report the results, right, as you'll recall, before I declare success and report the results, I probably need to go back and ask myself, what am I missing that may be important? And if I decide that, given my context, that this is all I need, then I can go on. So let's say, for our purposes, let's say we are satisfied with this model. Maybe we're just talking about a shorter trip, right? One bike ride to work or something, and I'm not worried about depreciation because it's not that many miles. I'm not going to have that many repairs for a 7-mile trip, that sort of thing. Then we want to report the results. And so then you have to decide, all right, if this isn't just me using it, if someone else is using our formula, is it good enough to just hand them this formula? For some people, this might be okay. But you might want to think about, if you're making a product for someone to use, you might want to have like an online calculator, right? Or maybe a spreadsheet where you can just ask the person to type in some numbers and then it spits out the answer for them, and they don't have to do any calculations on their own. So consider an online calculator as one example of implementation. But you would also want to report the limitations and the weaknesses. So you would want to advise of weaknesses. So for example, we said depreciation would be a more important factor if we were driving a lot of miles. So in that case, you would want to maybe say on your online calculator, this is only good for short trips. All right, and for longer trips, then you could have a second calculator that incorporated some of these other variables. And if you were having a situation that was even more broad than our original problem, then you could include insurance and taxes. So that's the modeling process. We will get more in depth of each of these stages in future videos, but that's it for now.